Probability Day 3. Today we're going to use tree diagrams to help organize our thoughts and our events in order to calculate probability. We'll begin by reading the question and setting up the tree diagram. So in example 1, it says you flip the same coin 3 times in a row. And we'll assume that a coin is a coin that we're familiar with that has a heads or a tails. So I'm going to start with a branch. On the left hand side of the screen, you'll see I have two different options the first time I flip that coin. The first option is I get a heads, and the second option is I get a tails. Now we don't actually call these options, we call these outcomes. So the outcome of flipping the coin is either a head or a tail. So this would be our first flip. Then we're going to flip the coin again. So we already have one event. So after we flip this again, we can either get a head or a tail, again from the outcomes. So we make two more branches, and this is the second flip of the coin. Then we'll do our third flip, and again we have two different outcomes every single time we flip that coin, and that is our third. So if we read across the branches, we have our completed outcomes. So with this first branch, if I just highlight this, this is one possible outcome because we know that we have to flip the coin 3 times. So we have a heads, and a heads. Our second outcome would be a heads, and a tails. Our third outcome would be a heads, a tails, and a heads, and a heads. The next one would be the heads, the tails, the tails. Then we go to that lower branch, tail, head, head. Oops. Then we have tails, heads, tails, 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 heads, and lastly, tails, tails, tails. If we add these all together, 1, 2, 3, 4, 5, 6, 7, 8, we have a total of 8 different possibilities that we can get when we flip the same coin 3 times. Now remember, these are also independent events because what we flip the first time will have absolutely no impact on what we flip the second or third time. So A says draw a tree diagram showing all possible outcomes. So again, our possible outcomes are these, all the different combinations. How many outcomes are there? So there's a total of 8 outcomes. How many paths have the heads 3 times in a row? Well, we only have one path that has it 3 times in a row, and that's that first path, 1. What is the probability of heads 3 times in a row? So if we only have one path, that means that we have 1 out of the total of 8 outcomes. How many paths have 2 heads and 1 tail? So I'm going to look at my list of outcomes, 2 heads and 1 tail, here, here. So it doesn't matter which order they're in, it's just how many have 2 heads and 1 tail. So that means we have 3. So we have 3 that are 2 heads and 1 tail, and then it says what is the probability of 2 heads and 1 tail. So the probability would be 3 out of a total of 8 outcomes. So really a tree diagram is just helping us create a visual of the event that is described. For the next example, which is labeled example 4, a coin is tossed, then a round spinner with sections labeled A through E is spun. Draw a tree diagram to represent all possible outcomes. So we're going to start with the tree diagram. So we have a coin that is tossed. Again, we will assume that it is heads and tails. So that is our coin. And then we have a spinner, A through D. A, B, C, D, E. So that is 5 different sections. So A, B, C, D, E. Then we need another 5 branches off the tail. One, A, B, C, D, E. I'm going to list the outcomes. So this is the spinner. So when we list the outcomes, we have a head and then A, head B, head C, head D, head E. We have a total of 10 outcomes. So how many outcomes are there? There are 10 possible outcomes. Which paths have a spinner that lands in section A? So we have the head A, and then we have the tail A. So the outcomes are head A and tail A. What is the probability of section A being spun? Well, there's 2 outcomes that have section A, so it would be 2 out of 10, or simplified to 1/5. What is the probability of section A being spun and the coin being heads? So the only thing that we do is we get rid of the one that has tails in A. So this would be 1 out of 10. And the reason why we're putting it out of that total number of outcomes is because that word probability is in there. What if section A was twice as big as the other sections in the spinner? Would the probability still be the same? So if that section was not an equal part, that means there was more opportunity for the spinner to actually land on A, so the probability would be no. They're not the same. So in the last 2 examples, we talked about how to set up tree diagrams, how to identify outcomes, and then how to find very simple probabilities. But if we actually want to calculate probabilities across the trees, what we do is we multiply the probabilities that are given to us. So remember, we were talking about events where the first event had absolutely no impact on the second event. So that means that they're independent events. And with independent events, we multiply those probabilities together. So in this example, we have 2 archers and we're trying to find out what the probability is that they both hit the target. We're given the probabilities in the question. So we're told that a hit for Lee is 3/4 and a hit for Yuka is 4/5. So if we want to identify the probability of them both hitting the target, now these are independent events that Lee hits and Yuka hits. There's an and there. So we're going to multiply those numbers together. So if you look over on the right hand side, a hit and a hit is multiplying that 3/4 by 4/5. So in these questions, we're actually going to set up our tree diagrams, assign those probabilities, and then not just find what the outcomes are, but find what the probabilities of the outcomes are. So in this example, we're going to make a tree diagram. We have 3 bags that contain different numbers of blue and red marbles. Now what you'll notice here is that we're assigned probability for how we select the bags, and also we have a different number of red and blue marbles inside each bag. So it's not the same as a coin where we have that theoretical probability where we know that a coin has a heads and a tails. We have experimental probability here where we're told and what the odds are of picking any specific event. So we'll start with picking the bag. We have 3 different options. We have bag A, bag B, and bag C. Now we're told in the question, a bag is selected using a die. So we know that a die has 6 sides. And it has 3 A faces, 2 B faces, and 1 C face. So that means that the odds of picking each bag are a little bit different. So if we have 3 A faces, then that means that 3 faces out of the 6, we're going to pick the A bag. 2 B faces, 2 out of the 6 of the die, we could land on B, and 1 C. Now we just want to check and make sure that this probability adds to 1. If you look at the numerators, we have 3 plus 2, which is 5, plus 1, which is 6. So that means that we're going to land on one of the bags. One marble is then selected at random from a bag. So if you look at the bags over on the right-hand side, we're told the number of red and blue marbles. So we have a red marble and we have a blue marble. In each bag, you'll notice that we have 5 marbles. So in bag A, 3 of the 5 marbles are red. In bag B, 4 of the 5 are red. And in bag C, 2 of the 5 are red. Going back to bag A, 2 of the 5 are blue, 1 of the 5 are blue in bag B, and 3 of the 5 in bag C are blue. So let's put together our outcomes. So here are the outcomes. The first column is the bag, the second column is the color. Now we're going to determine the probability for the outcomes. So the probability means that we're going to multiply down the branch. So for bag A and red, we have 3/6 times 3/5. Then we have 3/6 times 2/5 for bag A and then blue. For bag B and red, so I've written all my probabilities. Now I'm going to go and calculate them. So I'll multiply numerator times numerator, denominator times denominator. So I multiplied these probabilities together. I have not simplified them yet because looking ahead in the question, it says determine the probability that the marble is blue. So I'm going to have to add some of these probabilities together. So I'm just going to keep the denominator the same. That's why I'm not simplifying them yet. So for A, what is the probability that the marble is blue? So I'm going to take all of the probabilities that have an outcome where the marble is blue, and I'm going to add them up. So meaning that we could have the event that it's bag A and blue, or we can have bag B and blue, or bag C and blue. So notice how I said that word or? That means that we're adding those probabilities together. So 6 out of 30 plus 2 out of 30 plus 3 out of 30. We add those all up and we get 11 out of 30. So that's the probability of blue. For B, it's asking for the probability of red. So the probability of red is 9 over 30 plus 8 over 30 plus 2 over 30, which is 19 over 30. In example 2, use the following diagram and the information to find the probabilities. 3 friends try out for sports team at their high school. Gladys tries out for the lacrosse team and has a 40% chance of success, meaning making the team. Becky tries out for the synchronized swimming team and has a 30% chance of success. And Sarita tries out for the tennis team and has a 25% chance of success. Use the tree diagram to find the probabilities. So we have the tree diagram, but we don't actually have the percentages on there. The first one, we have a 40% chance of making the team. So success is 40%, so I'm going to put 40% on there. So we need to calculate what is the probability of getting a failure. 40% is a success, so that means that 60% is going to be a failure because it has to add to 1. Then we go to Becky. She has a 30% chance of success. So I'm going to put 0.3 for success, meaning that she has a 0.7 chance of failure. And we have to do that on both branches. And then Sarita has a 25%, so 0.25, and then 0.75 for failure. So we've put all of the probabilities on the tree diagram. What is the probability that all three girls will make their teams? So if all three girls make the team, we would have a success, and a success. Remember, these are independent events, and we're identifying if the first event and the second event and the third event occurs. So we will be multiplying these numbers together. When we multiply these together, we get 0.03. So that's a 3% chance. The next one says, what is the probability that exactly one of the girls will be successful? So we first have to look at which branches have 2 failures and 1 success. So I've highlighted the 3 branches. Then we take each branch and multiply it. So 0.4 times 0.7 times 0.75, and then we add it to the next 0.6 times 0.3 times 0.75, and 0.6 times 0.6 times 0.25. So what we're saying here is that each of these between the addition signs are events where we have 2 failures and 1 success, but any of those combinations can happen. So it could be the first combination or the second combination or the third combination. So if we add those up, we end up getting 0.45. So it's a 45% chance that exactly 1 girl will be successful while 2 are unsuccessful.